Previously, we focused on LSA types. Link state advertisements make this protocol a link state routing protocol. OSPF is a link state routing protocol. So based on the advertisements, the link state advertisements, the topology discovery happens. On top of which the database, on top of this database topology, which is also called as LSDB, the shortest path first algorithm, which is also called as binary tree algorithm, low cost path algorithm, Dijkstra's algorithm. So the Dijkstra's algorithm helps us to find the shortest path first, which is going to be installed into the routing table. But earlier I said, the previous class, that you can expect the topology table to be identical within an area. It is all because of type 1 and type 2 LSA, which is distributed to every router within an area. So this type 1, type 2 LSA, which is also called as router LSA and network LSA, they don't cross the boundary, they don't cross the borders. They are only advertised to the routers that belong to same autonomous system. Sorry, same area ID, not the autonomous. Right, so throughout the autonomous system, you cannot expect one common topology if you do summarization. So that's another reason. Summarization makes a different database in different area, which we learned earlier, summarization, ABR summarization, DSBR summarization. Then how one area knows about the other area? It is via area 0, type 3 LSA. So type 3 LSA from one area it goes to another area 0 only, repeating again. A type 3 LSA of non-backbone area will not go to another non-backbone area. That is not the way OSPF is designed. Type 3 LSA of one area goes to only area 0. And from area 0, it goes to non-backbone areas. ABR takes the responsibility to distribute this. So you will not see the next hop address of the original router that originates the update. You will find only the ABR router ID in the updates, even in the database. Which is summary LSA. Type 3 LSA is called a summary LSA. There is also another autonomous system summary LSA, which is generated from the ABR of the area, which has got ASBR. And this LSA carries the router ID of the ASBR. Finally, we saw type 5 LSA, which is bringing the external routes into OSPF. So obviously this will be originating from the router where the redistribution is done. We also learned about E1, E2 typecast. The default is E2. What does that mean? While redistributing from some other protocol source, while distributing the routes from some other source into OSPF, the cost that is given to those external network will be maintained to any number of hops inside the OSPF domain. In another word, the path cost is not going to be added. That's type 2. Type 1 is path cost added. Path cost is added, type 1, for which we need to configure metric type 1. The default is 2. The metric that is added by default while redistributing is 20. But you have option using a command called metric to give a seed metric. Seed metric is a metric. Seed metric is a metric that can be given during the redistribution time. The default seed metric is 20. So the seed metric will keep growing if it is type 1. Next. Okay, we have seen all these things. Now, we will not be getting into type 6 and 7 now, maybe later. We are in this topic called stub. So today our focus is, as per the discussion, we will be focusing on OSPF network types, in which we are going to see Nbma, non-broadcast multi-access. That's the meaning of Nbma, non-broadcast multi-access. What is non-broadcast multi-access? When you have OSPF running within an organization, it is considered as broadcast. You'll be having a lot of Ethernet technology as a layer 2 encapsulation. But even if you have a serial wire, it is still within an organization. It is not a non-broadcast. It's a point-to-point. But when we are connecting through a frame relay, I do not want to tell all other terminologies which you are not going to really see in the real world, like X.25, ATM. Who wants it, right? So if you will have a frame relay environment, which you may know, yeah. So frame relay, you might have heard about. So I'm using frame relay as an example. As a non-broadcast network, whenever we got sites connected through the transport frame relay is the transport between the sites. Whenever frame relay is a transport, we cannot do any broadcast between these sites. Actually speaking, you'll have a serial link. Serial link only can encapsulate using frame relay. See, this is not that important, but To understand Nbma, it is important. Yeah, so frame relay is running on this interface, on this interface, on this interface, on this interface, which is also running OSPF, assume. Now, according to OSPF, it is running on a non-broadcast multi-access or non-broadcast link, meaning I cannot do broadcast. If I'm not able to do broadcast, I'm not able to do multicast also. If I'm not able to do multicast, I cannot send hello packets. If I cannot send hello packets, I can't learn neighbors. Neighbors can't learn me. So non-broadcast multi-access or non-broadcast environments don't support multicast. But you want to form neighbor between these four routers using OSPF. You want to distribute the routes between the sites. But what you have in the middle is frame relay. If MPLS, no problem. But you got frame relay. Yeah. So when we have frame relay, OSPF will not form neighbor by default. The reason is OSPF knows that I am connected to a non-broadcast. In another word, if I need to say, in Nbma environment, non-broadcast is the network type. Non-broadcast is the OSPF network type. We are going to learn 5 different Nbma network types. The first one here, what we say is Nbma non-broadcast. Secondly, what we will see is point to multipoint. Thirdly, what we will see is, I'll write this one in short, point to multipoint, and this one non-broadcast. This is the third type. Point to multipoint, non-broadcast, which is the combination of first two. Fourthly, you have broadcast. Fifth is point to point. Please understand, this is not normal broadcast and normal point to point, which you learned earlier. Earlier we saw when you have a serial wire between two routers running OSPF, there won't be DR-BDR because it's a point-to-point network. And we also learned when you are connected through an Ethernet wire, it's a broadcast, so there will be DR-BDR election. This is not that broadcast. This is not that point-to-point. This is under Nbma broadcast. Under Nbma point-to-point. You may ask, what is the connection between non-broadcast and broadcast? Funny. It's contradictory. Non-broadcast, multi-access broadcast. What is this? Anyway, that's a type. Even though it is a non-broadcast, You want OSPF to believe that it is broadcast. You want OSPF to pretend as if you don't see a non-broadcast environment. And you want OSPF to behave as it behaves in a broadcast environment. How it behaves in a broadcast environment, we know this. In a broadcast environment, when you have Ethernet, hello packets are sent. As a result, neighbors are discovered, and there will be DR and VDR, and all the neighbors will be in same subnet. Yes or no? All should be in same subnet, no? Because broadcast. I drew a picture and I showed you in the previous class. And then the hello timers are 10 and 40. This is what you used to have in a broadcast environment, in a normal Ethernet environment within an organization. But in reality, even though it's a non-broadcast, it's not within the organization, it is between various sites. In the middle, you got frame relay. Even though you got an Nbma, you still can achieve all this. You can see OSPF doing neighbor discovery, electing DRBDR, having all the neighbors in same subnet, all the sites. WAN facing interface should be in same subnet. And the timer is going to be 10 and 40. Likewise, even though it is an Nbma network, even though it's an Nbma network, you want to have this kind of experience in this. What kind of experience you saw here? In point to point, priority is 0. Here the priority is 1. So the DRBDR election will be here. No DRBDR. Neighbors are dynamically discovered. Same subnet. Timers are 10 and 40. This is the only big difference. Point to point. No DR, no BDR, because it's just two routers. So you want to have this experience in this environment where you got frame relay in the middle. In such occasion, you can go and change the OSPF network type as Nbma point to point. If I want a frame relay with multi-access to be broadcast, then I will go and change the OSPF network type on all the frame relay interface as broadcast Nbma. So I hope that you got these two type in Nbma, two modes in Nbma. Two modes in Nbma. Next is this one, non-broadcast. This is the default mode. What does it mean? Whenever you enable OSPF on a frame relay running interface, OSPF will say, I'm in a non-broadcast environment. So what? So I cannot discover neighbors dynamically. I cannot discover dynamically the neighbors. Which means I need to manually configure the neighbor. What else? But there is going to be a DR-BDR match. So there will be one DR and BDR. There will be a DR, there will be a BDR elected. Fifthly, the timers. The non-broadcast multi-axis, the hello timer is 30. The day timer is 120 seconds. See, this is not the default timer in OSPF broadcast. In OSPF broadcast, it is 10 and 40. Even in Nbma broadcast, you saw the 10 and 40 in both broadcast as well as in point-to-point. But in all other three, the timer is 30 and 120. So this is hello timer. So there is no difference in timer in the first three. Anyway, second and third we have not so far focused. Wait for a minute. Let's finish the first one properly. Whenever you run OSPF in this frame relay environment, there's 1, 2, 3, 4 routers. They run OSPF on the frame relay serial link. Frame relay is the transport. Frame relay is tunneling technology which provides PVCs, permanent virtual circuit. It is a waste of time, I tell you, but I have a video of this recently uploaded, recorded in some other batch, the frame relay configurations. You can have a look into that video. If you want my support, I'll get the link for you. Now, transport is frame relay. That's going to provide you the reachability. But forming neighborship is not automatic because neighbors need to be manually configured in this default mode called non-broadcast. And you see, because the DR and BDR is elected, the topology recommended is mesh. Mesh topology. The topology that is recommended is mesh topology. Meaning all the sites need to be connected to all other sites. Every site should be connected to all other sites via frame relay. What does that mean? Let's go back and see. This and this need to be connected, 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 connected. Is there anything that don't have direct connection? all need to be connected like this. Only then, if this becomes a DR and if this becomes a BDR, and let's say this DR goes down, and this will become DR and this will become BDR. If you don't have full mesh, let's say you don't have full mesh, you just got hub and spoke, you don't have full mesh, and let's say this is DR and this is BDR and these are all others. Now if this DR goes down, what is the use? This will become DR. What is the use? Can this talk to this one? No. No. Can't. So after some time this will say, hey, I am also DR. No one is talking to me. I am also DR. No one is talking to me. It's of no use, you see. There is no hub. And the DR is no more. So because there is a DR BDR election, you should not leave this default network type non-broadcast. If you don't have full mesh topology, you should not go for this default mode. You need to look for some other mode that is compatible with hub and spoke. So the recommended topology is mesh topology. Let's move on to the next one. The next network type is point to multipoint. This is not default, right? This is not default. The default is non-broadcast. So need to be configured. In this, neighbors are dynamically discovered. See, that's one big difference. Here, no dynamic discovery. Neighbors are manually configured. Here, neighbors are dynamically discovered. And here, there is no DR BDR. There is no DR BDR election. So this is recommended for hub and spoke. Or partial mesh. But better, no? Hub and spoke. So you got the difference. Point to multipoint and non-broadcast. These two are the real RFC standard, R1 and R2. If you are working on OSPF Juniper, you will have only these two as a network type, Nbma network type. You won't have the other three that we have only in Cisco. The third, fourth, and fifth is only available in Cisco. Now, what is the third one? Third one, if you see, it's a combination of the second one and the first one. In the second one, the best out of the second one is which one? The best out of the second one is no DR BDR election. See, because it is no DR BDR election, it can fit in any topology. You see, that's an advantage. What is the best out of first one? Neighbors are manually configured. Is it the best one? Of course it is the best one. Why? Because it's an Nbma. Because it's between multi-sites. Because it is between multiple sites, remote sites, we don't trust. We don't trust. We don't want someone saying hello and forming neighbor with us and giving us some bad route information. We appreciate the manual configuration of neighbor in an Nbma design. So this is the best out of the first one. This is the best out of the second one. So you can use this in full mesh or partial mesh anywhere. Timers are set. So we have covered all 5 modes of Nbma. The default is non-broadcast. Now, why do we study when we are not going to have frame relay? Why do we need to study this? Why are we studying this? Even though it is a non-broadcast mode, if you wish to configure these policies, these are all policies, right? 5 different policies. If I configure an interface to be a point to multipoint, policy number 2 will be applied between the neighbor. Yes, that's the secret. Even in an Ethernet environment, you can choose any one of these, whichever suits your policy. In an Ethernet environment, what is the default? Broadcast, where neighbors will be dynamically discovered, but you don't like it. You don't like it at all. Then what you can do is, you can go and set it as non-broadcast. You can tell OSPF, I'm telling you, believe me, it is non-broadcast. Then OSPF say, Roger, sir. I copy it. It's a non-broadcast, sir. I'm not going to discover the neighbor anymore. I'm not going to send any hello packets. So I'll wait for you, sir, to configure the neighbor, sir. Yeah. So here we see 5 different Nbma modes, even though we call it as Nbma modes. You should see these as 5 different policies in forming adjacency in OSPF. And you can use any one of these in any environment. So you will see in the production, there will be an Ethernet wire. What is the Ethernet wire by default? Broadcast. But you will see some people configuring point to point. Why? Because even though it's just a 2 router scenario, because there is a Ethernet, there will be a DRBDR. He don't like it. So what he does, he says, hey, it is not a Ethernet, it is point to point. When he says OSPF network type point to point, then there won't be DR and BDR election. He do not want the DR BDR election. So though it is coming under the title called non-broadcast multi-access modes, for you and me, it is 5 different OSPF adjacency policies. Whichever suits your environment, you use it. So we are not going to have a frame relay cloud in this batch. I'm just going to have maybe Ethernet or serial, that type of environment, where I can still have an Nbma modes, 5 different policies. If you wish to see with the frame relay, I'll send you a link from our channel where I have demonstrated with the frame relay in the middle. Once you can just go through it. That's all. That's not that important, neither for exam nor for the production. But yes, please. Performances. Yes, that is right. No, no, no. Even if you have a Ethernet wire, you got a Ethernet wire where there will be a DRBD election, where there will be dynamic discovery of neighbor, which you don't like. You don't like the dynamic discovery of neighbor. You don't like the DRBDR. Then what you can do is you can go and enable point to multipoint non-broadcast on the Ethernet wire. Even though it's not a frame relay, you will see as if it forms adjacency in a frame relay environment where it is point to multi-point non-broadcast configured. So this last three are not RFC, they're Cisco's policy, Cisco's idea. These two you can see in common with all OSPF, all OSPF running appliance. Non-broadcast, where there will be no DRBDR election, where we also need to configure the neighbors manually. No dynamic discovery of neighbor, no DRBDR election. Timers are 30 and 120. It is suitable for any topology, any network or design. No, number two is point to multipoint, that's all. No, in a broadcast, neighbors are dynamically discovered. You remember? Here, neighbors are manually configured. That's a very big difference, isn't it? Yeah. Repeat again, please. Hmm. Now you also need to configure neighbor as you configure in BGP. In a non-broadcast, in the first one and the third one, you're going to configure neighbor in OSPF, under OSPF, as you used to configure under BGP. Apart from the network command, you also need to use neighbor command. Same like what you do in BGP. Anyone else have got any other question in this what we learned today? Mm-hmm. Mm. hub and spoke, then you can go with the third one. If all the devices are Cisco, if all the devices are Cisco, you can go with third one. Otherwise, you can go with the second one. The first one, the default one, yes. You no need to even configure it, it will be default. Mm, mm, yes, yes. As I said, in a hub and spoke design, there is no point of electing a DR and BDR because if a hub is a DR and if the DR goes down, all will get disconnected. No spokes and spokes can communicate without a hub. So there's no point of having DR and BDR. Better to go with point multi-point as an option. Any other question from anyone of you? If the topology is what? Ringer. It's not full mesh. It is not full mesh. It is not full mesh. It is not. It's not point to multi-point also. Yeah, of course, point to multi. No, it's not even point to multi-point. It's not beyond point to. It is. It's like point to point. So it's like point to point because you said ring, which means here is going to be 10 network, assume 20 network, different subnet. So point to point only can support multiple subnets. So this is the option for you. Last one. Right? Fine then.